geometry students. We're in section 5.5, kind of middle of our chapter now, and we are going to move into something else called an indirect proof. And you're probably like, no, not another proof. And this might actually prove to be really fun. I don't know. Let's kind of talk it out. Your book tells you that so far you have written proofs using direct reasoning. So in other words, you had corollary theorem, some sort of way that you proved it. You began with a true hypothesis, and then you built a logical argument and showed that the conclusion had to be true. Now, what we're going to do with an indirect proof, this is going to sound really weird. You're going to begin by assuming that the conclusion is false. And then you show that this assumption leads to a contradiction. So we're going to do some algebra to maybe drive some numbers, let the numbers prove that there's a contradiction, that this isn't possible. And what we call this type of proof is a proof by contradiction. I know that sounds weird, but that's what we're doing. We're looking for a contradiction. So there are 4 basic steps that we're going to follow. The first is we're going to identify what we're trying to prove, okay? And they're going to give us enough information, we'll figure it out, and I'll show you in the next example how to do that. The second step is we're then going to assume the opposite. We're going to negate the conclusion as being true. We're going to negate it and say and try and prove the opposite is what we're going to do. Then we're going to use direct reasoning. We'll switch back to the direct reasoning we're comfortable with using, and we have been using in all the other proofs, so using all the corollaries and postulates and theorems and definitions that we've already learned, and then make a conclusion based on that contradiction. Okay, so the steps here make it sound worse than it is, I think. I think once I show you, you're going to go, oh, that's not that bad. So, all right, example 1, we're going to write an indirect proof, and we're going to do it in these 4 steps. So, step 1, here's the directions. Write an indirect proof that a right triangle cannot have an obtuse angle. Okay? So, the first thing that I need you to write down is that we are given, oh, that's real blobby. Let me bring that down just a little bit. I apologize in advance for that being so gross. All right, so given, that's better. Given, we know that triangle JKL is a right triangle. Okay, we know that. The figure is showing that. We're given that in that first statement. And the second thing, our proof in this particular case is going to be that triangle JKL does not have an obtuse angle. Okay? So this is what was given. We know that we were given this, and the figure supports that, and we're told that we have a right triangle. And this is what we're trying to prove. Prove that it cannot have that one of the angles is obtuse. That's really what we're after. Okay? So step 2, now we get to assume the opposite of the conclusion. The conclusion is triangle JKL does not have an obtuse angle. Well, what we're going to do is we're going to say the opposite. We're going to say triangle JKL has an obtuse angle. So that's the opposite, right? And so we're going to prove the opposite using direct reasoning, using all the definitions and properties that we're aware of, okay? We're looking for a contradiction. So in this case, let's let angle K, let's make that our obtuse angle just for the sake of picking one of the angles out. It could have been L, it could have been K, it doesn't really matter. Let's, just for the sake of solidarity, we're all going to do angle K is the obtuse angle in this triangle, okay? So now we're going to use direct reasoning to lead to this contradiction. In right triangles, do you remember learning that the acute angles of your right triangle are complementary? So whatever K is equal to, whatever L is equal to, they're going to add up to be 90 degrees. Okay, we know that the acute angles, the other angles that are not the right angle, that they are actually complementary. They add up to be 90 degrees. Okay, now the measure of angle K, what we're going to do is we're going to subtract L from each side, and we're going to end up with the measure of angle K equals 90 minus whatever L's measurement is. Okay? So that's just a little bit of basic math. We did the subtraction property of equations to isolate the K. You did that in algebra a lot. We also know if we're assuming that K is our obtuse angle, so we know that the measure of angle K has to be greater than 90 degrees. That's the only way that it's obtuse, is if it's a number that's greater than 90 degrees, and that's the definition of an obtuse angle. So now what we're going to do is we're going to create an inequality. Okay, we're going to do substitution, and we're going to say, okay, instead of writing the measure of angle K, I have another name for the measure of angle K right here. I'm going to say 90 minus the measure of angle L is greater than 90 degrees. Okay, so that's what we're looking for. That's we're able to substitute that in. This is another name for the measure of angle K. Now we're going to do some basic math, and we're going to do subtraction property, and ultimately we're going to do subtraction and division property. We're going to take away 90 from each side, and so we'll have negative measure of angle L is greater than 0 degrees. And I'm going to continue it up over here. Measure of angle, the opposite of the measure of angle L is greater than 0 degrees. Then to get rid of that negative sign, remember that's really merely a -1. We're going to divide each side by -1. Oh, you got to remember the rule here about, you know, when I multiply or divide each side of an inequality with a negative number, what's going to happen to this symbol? It's going to flip. Okay, and you can't have a +0 or a -0, so really that -1 is not going to affect the 0, but it does flip your symbol over. And so now we're here, we're like, well, the measure of angle L has to be less than 0 degrees. And so that's where your contradiction occurs. That's what we're looking for. So put a box around that and go and write the word contradiction. Because when you do an indirect proof, that is what you're after. You're looking for the contradiction, and it was all from that direct reasoning that we used, you know, all the stuff we learned along the way. Acute angles of a right triangle are complementary, and then creating a subtraction problem out of that and isolating angle K. That's direct reasoning. We have a reason we can do that. There's a mathematical reason for that. Okay, so now we go, but wait a second, can you have an angle that's less than 0 degrees? And no, the protractor postulate says that a triangle cannot have an angle with a measure less than 0 degrees, 0 to 180. You know, that's the protractor postulate that we learned early on. So now step 4 says, okay, conclude that the original conjecture is true. And so the assumption that triangle JKL has an obtuse angle is false. Therefore, because you were able to find a contradiction, therefore, triangle JKL, and you would just say, does not have an obtuse angle. Okay? So once you find that contradiction, then you can make this conclusion right here in step 4 about that triangle. Okay? Now, if it did have an obtuse angle, then you wouldn't see a contradiction. It would work out. You'd be like, well, that's true, and so there would be no contradiction. So note the steps that we took. We figured out what our given was. We figured out what our proof was. That's step 1. Step 2, assume the opposite of your proof. Now your proof in this case said triangle JKL does not have an obtuse angle, and we said that it does. And we operated on that particular thought process, on that negation. And then we used step 3, that's where the algebra came in, some algebra came in. And we rearranged some equations and we substituted and we actually proved there's no way that, that it could be obtuse. And so that's why we can make that conclusion. All right, so check it out as yours. You get to try this one. Write an indirect proof that a triangle cannot have 2 right angles. Write an indirect proof that a triangle cannot have 2 right angles. Okay? So give that your best shot, and if you're having a hard time, text me. I'll try and help you get that started if you're not sure how to get that started exactly. Okay? But I do want to leave it and see if you can do it on your own. All right? Good luck, and bring your questions to class.